This is a problem on the Archimedes principle. I have translated it from Italian. Let's read the problem. An iron sphere with given volume and density, and the density is rho Fe, which in Italian stands for ferro, it means iron. So this is the density of iron, rho Fe. Vfe is the volume of the sphere, of the iron sphere, and this sphere is immersed in water and is upheld by an unstretchable rope with negligible mass. The upper end of the rope is attached to another sphere made of wood, also immersed in water, and the density of wood, rho L, L stands for legno in Italian and it means wood, is also given. This is just notation, you can call them whatever you want, so I simply use the Italian notation. Determine the volume of the wooden sphere which is necessary to balance the system. Let's sketch our problem. So we have the surface of the water. Here we have the wooden sphere. So it is characterized by a volume VL. And there is a force which is, let's say, due to the weight of this wooden sphere. So it is the density of wood times the volume VL times G. So this is the mass of the wooden sphere times G. This is also, let's say, thwarted. So there is an opposing force which is due to the Archimedes principle. So we have something very similar. We have the density of the water, that I will call it rho A. A stands for aqua, so it's water. And then we have VL times G. This is simply due to the Archimedes principle. So we have the volume of fluid that's displaced by this sphere multiplied by the density multiplied by G, and that's a force. And then we have a rope which is connecting this sphere to the other sphere, the iron sphere, and this iron sphere is characterized by the volume VFE. And similarly, we have a force acting on this one going upwards due to Archimedes' principle. So we have rho A, density of water, times the volume of the iron sphere times G. And then we have another one pointing downwards, given by the density of iron multiplied by the volume of the iron sphere times G. All in all, here we have four forces. And we can simply consider the sum of the forces pointing upwards, and we have to set it equal to the sum of the forces pointing downwards. So we have rho A VLG plus rho A VFEG. So this is the volume of the iron sphere. These are forces pointing upwards, and this is equal to the sum of the forces pointing downwards. Rho L VL G plus rho Fe VFE G. So we can simplify the constant G, the gravitational constant, and then here we can rewrite it as rho A minus rho L times VL, so the volume of wood, the wooden sphere, and this is equal to rho Fe minus rho A VFE. From here we get VL equal to rho Fe minus rho A divided by rho A minus rho L VFE. So the density of water is about 1000 kilograms per meter cubed, per cubic meter. And the problem gives this density, and also this volume here, even if we don't have the numbers. So I didn't want to also insert the numbers, but those are, let's say, that's given data, right? So this is the final formula which should be used to solve the problem.